Okay, let's unpack this. Preserving muscle as we get older is absolutely crucial.
It really is. It's not just about brute strength.
Exactly.
Yeah.
It hits our metabolism, how we move, our overall health span, really.
But facing that age-related muscle loss,
Hmm.
sarcopenia as it's known,
Hmm.
that's a real challenge for a lot of people.
It is. And while obviously exercise is fundamental,
It's a cornerstone, yeah.
the science is definitely looking at some, well, new frontiers. Today, we're diving into some pretty fascinating drug therapies.
Targeting specific proteins, right?
Yeah.
The ones involved in muscle growth and breakdown.
Right on. And for this deep dive, we're pulling from sources like the article Combating Age-Related Muscle Loss, Myostatin and Activin A Inhibitors.
Mm-hmm.
Our mission is basically to figure out what are these proteins, myostatin and activin A, how do these new drugs work?
And what are the results looking like so far? What are the big questions still out there for you listening?
Yeah, why should you care about myostatin and activin A?
Okay, so myostatin and activin A, they're related proteins.
Yeah.
Part of the same family called TGF.
TGF-FT, got it.
Think of myostatin as like a really powerful natural brake on muscle growth. It tells your muscles, okay, don't get too big. It inhibits hypertrophy.
The build-up phase.
Exactly. Activin A, though, it's kind of the other side of the coin. It promotes muscle breakdown catabolism.
Ah.
And it does other things, too, involved in inflammation, reproduction, and importantly, it can act as a tumor suppressor in some cancers. Liver, prostate, that's relevant later.
Okay, so these therapies, the goal is basically to take the brakes off muscle growth, maybe slow down that breakdown process too?
Precisely. Companies are working on antibodies, biological drugs designed specifically to block these proteins.
Like Regeneron, I saw they have a couple.
Yeah, exactly. Trevogrumab, that one blocks myostatin.
Yeah.
And garetosmab targets activin A.
Okay. And have there been results, early looks?
There have, particularly in preclinical work, animal studies. And they showed pretty promising effects there, increasing muscle mass, reducing fat. And this is a really critical point for you to remember.
Okay.
Earlier tries with myostatin inhibitors, they looked amazing in animals. But when they got to human trials for muscle diseases, the results were, well, modest.
Ah, so the animal model doesn't always predict human results perfectly.
Not always, no. That's a
No.
crucial distinction.
So what about actual human trials with these newer ones? Any data coming out?
Yes, actually. Some preliminary data was mentioned from the phase 2 COURAGE trial.
Courage trial. Okay. What's that looking at?
It's interesting. It's testing a combination of these antibodies, blocking both myostatin and activin A in patients who are also taking semaglutide.
Oh, the GLP-1 drug for weight loss.
Exactly. Because sometimes people on GLP-1s lose muscle along with fat. So the idea is, can these antibodies help preserve that muscle mass?
Okay, makes sense. And what did the initial data hint at?
Well, the early report suggested that the patients getting the antibody combo seemed to hold on to more muscle compared to those just on semaglutide.
That sounds promising, at least for the muscle size part.
It does. But this is preliminary. Very early. The full results aren't published or peer-reviewed yet. We need to see the details.
Right. Context is everything. And you've emphasized before, muscle function isn't just about size, is it?
Absolutely not. And this might be the most important takeaway for you. Just making muscles bigger with a drug doesn't automatically mean they'll work better.
How so?
Well, muscle function, strength, power, coordination that depends heavily on your nervous system talking to the muscle fibers effectively.
The neuromuscular connection.
Precisely.
Yeah.
And also the internal quality. It's the structure of the muscle itself. Aging can compromise those things, like losing motor neurons.
So just inflating the muscle pharmacologically might not actually improve your strength or mobility in a meaningful way?
That's the concern. Muscle gain just through these drugs might not translate fully into better function unless you're also doing the work physical exercise.
Ah, exercise provides those essential neuromuscular adaptations, the brain-muscle link.
You got it. That's something the drugs alone likely can't replicate.
And I imagine blocking fundamental pathways like TGF-A, there must be safety things to think about.
Definitely. Big time. Inhibiting these pathways long term, well, it could affect other tissues, not just muscle. Bone, potentially the heart. And remember activin A's role as a tumor suppressor.
Right, in liver and prostate cancers you mentioned.
Yeah. So blocking it long term raises questions. We absolutely need comprehensive monitoring for any potential long-term risks, cardiac issues, maybe tumor development.
That sounds like it requires a lot of data over time.
For sure. For widespread preventative use, you'd likely need years, maybe 5 to 10 years, of solid post-marketing safety data.
So, bottom line, these aren't looking like a magic bullet replacement for good lifestyle habits.
Not at all. Not even close. Think of them as potential tools in the toolbox. Maybe they could complement things like exercise, nutrition, other longevity strategies. But replace? No.
Okay, so let's sort of recap. We've looked at how blocking proteins like myostatin and activin A shows some promise, at least for increasing muscle mass.
Citing drugs like trevogrumab, garetosmab, and that very early data from the COURAGE trial suggesting muscle preservation might be possible.
But we've also hit the crucial nuances. Function really matters, maybe more than just size.
Right. And these drugs alone probably won't give you the full systemic benefits you get from exercise. That neuromuscular training is key.
And critically, safety. Long-term inhibition, especially with activin A's complex roles like tumor suppression, that demands caution and years of data.
Absolutely. Need thorough investigation before we could think about broad use.
So thinking ahead, we have these potentially powerful new pharmacological tools emerging. How do you, listening, imagine a future where these might fit alongside fundamental habits like exercise and good nutrition?
Yeah, what does healthy aging truly look like when we start factoring in both pharmacology and lifestyle? It's definitely something interesting to consider.